there's a sign-in sheet. If you can, please go ahead and sign in. The notes did not go out last time because I was thinking I was going to try to re-record the audio and part of it. But I think I'll just release the actual slides because you can go through them and actually figure out the other parts. This intermediate part, I just added on to the end of the other slides so that when we send out the notes, you'll have just all of the Git training all in one place. You don't have to go and look at different places for different parts of it. We haven't scheduled the advanced one yet. And what I was going to do is ask and see if we actually need to do that one based on what we're going to cover today. There's a lot more to it, but frankly, a lot of stuff even that we're going to cover today, I don't even use on a day-to-day basis. Mostly what you need was last week. And so who was not here last week? Not here. Okay, cool. We'll do a brief overview really quickly, but the notes, when you get the notes, there's walkthroughs. So last week was very hands-on, everyone's typing the command line and doing that. We're not going to be as hands-on today. It's more theoretical type stuff. Sorry, I didn't update the email. I just copy and pasted the last one, highlight part 2. While we're here, like I said, we're going to standardize around Git as our source control tool. It's important. It helps us to not have to redo plumbing. Actually, let me do this. All right, cool. What is Git? It's basically a distributed version control system. It's free. It's open source. Why do we need source control? We mentioned a couple of times people lost work. I've lost work. People have overwritten things. You forget why things have changed. So the why and the history as well. Experimentation. Also, a big part of this is that it's a foundation for automation. How do we choose Git? We had a task force that we put together, and the notes will be there that comes out. And we had a list of criteria that we used to determine which source control tool we're going to go with. Here's where we went through and actually went into the actual working process of this. And so we're going to skip all of that for today. If there's questions that come up as we're going through, even if you were here last time, just ask the questions, because I think that's why I was really trying to do the audio part, because the question and answer part, that it's not going to be in the notes per se, but that is a lot of value added. So I think last time we had a lot of good questions that was asked. So I was trying to figure out a way that we can get that in to the notes that goes out, but still haven't gotten there yet. But if you have your questions today, this is all about you guys, and as you guys ask questions, I learn a little bit too as well. Or someone else in the room may know the answer and they can respond as well. So today we're going to do intermediate Git, which is, I guess, more advanced than beginner Git. We're really all the same. It's all Git. I just need to break it up into 2 different sections because it was too much to do all at one time. So this one won't be as hands-on as the last one, but I did actually go through and do the slide thing where you don't see all of my slides all at once, so you're not reading ahead. All right. So starting off, we talked about commit messages. Commit messages give you the context. Every time you do a commit, it's going to ask you for a message. And so how do you do good commit messages? Any thoughts on that? What's a good commit message? Damon.
I would say details on what changes were made with the user's name, date, and time. Okay,
sounds good. Sounds good. So the user's name and the date and time, Git's going to give you automatically. All right, it'll put that in for you. So why does it matter? So Git commit messages tell the history of your code or your script. Right? I'm going to use code, but for the essays in the room, you're probably going to be writing scripts. This just translate one to the other. Right? So they give you the history of your code. Right? They give you the context around that change, the why of that change. Right? So the changes in the code is going to be the what and the how. Your Git message, you really want it to be the why. Why did you actually make this change? All right. So there's a link in here. This Chris Beams, he wrote a post on how do you write a good commit message. A lot of things that we have in here is coming directly from that. Actually, all of the things that we have around a good commit are coming from there. He does a really good job of explaining in detail exactly why he puts each one of those things in there. I think once you get the notes, it's a good place to go and take a look at. Let's see if we can browse over there really quickly. So this is his post. Like I said, it's depending on how fast you read, it's maybe about 15 minutes, 10, 15 minutes. But it gives you a breakdown, like each one of the steps that we're going to go through, the highlight, each one, like the area here where it says capitalize the subject line, he goes into exactly why he says that. So it's really, really a useful thing to kind of look through. All right, so you want to limit your subject line to 50 characters. And I think we're going to jump ahead a little bit here, but you want to break your get commit message into a subject line, or like let's say it's a topic at the top, and then a body down below that. Now the body is optional, but the reason why it says limit this to 50 characters is one, so that when you're reading through all your commit logs, you can easily see really quickly just a high level summary, and you can dive deeper into that if you need to. But also a lot of tooling cuts it off at 50 characters. So if you had some really important things to say and you said it like character 60, guess what? You just don't see that when you're looking through the top level logs. So you want to limit that subject line to 50 characters. All right. Capitalize the subject line. That's, I think, a style thing. I don't think it necessarily matters, but he thinks it does. Do not end the subject line with a period. Again, I don't think that matters, but I think his reasoning for that is that your space is limited. So each character actually counts. So if you only have 50 characters and you're wasting one of them for a period, when frankly, devs and essays and people reading this code don't really care that much about the grammar of it, all right? Then you don't want to waste that space. All right, as we mentioned, we're going to separate the subject line from the body with a blank line, and that'll help the tooling. So as you're going through and you do git log, or you're looking at your TFS or your GitHub or whatever the case may be, when you have that blank line in there, it'll stop there, and so you don't get all this extra gobbledygook in there. This one I think was interesting. So you'll see a couple of these are in yellow. And the ones that are in yellow are the ones I was trying to say I think these are more important than some of the other points. I don't know what's going on with my screen here. All right, so use the imperative mood in the subject line. Anyone know what the imperative mood actually is? No, I did not either, but I'm not a grammar person, so I figured that was just me. All right, he makes a really good point. We'll touch on some examples of that, but you want to make it so that you're saying a command, right? You're not going to say like, well, actually, I'll give you a few examples of that in a minute. But it's going to be more so that it's a command or instruction, right? That's how you want to phrase your terminology. And it'll make more sense on the next slide. So again, spoken or written as if giving a command or instruction, right? So you want to wrap your body at 72 characters. Not that your body can only be 72 characters, but every 72 characters, you want to hit a return line, right? And again, that's for the tooling. So when it shows up on your screen, it shows up properly. When you're either in the command line or in a tool, it'll format it properly. Things that seem like they don't matter until you get one where it's scrolling all the way off to the right and your tooling doesn't scroll, or something's weird and you can't understand it. So little things like that. But again, the more important one, use the body to explain the why. That's backwards. The why and not the versus the what and the how, okay? So that's really what you want to use it for. So remember we talked about that imperative mood. So here's some examples of that, and you'll see some counter examples of that. So you want that part there where it says your subject line here. Imagine that's your subject line. So that's going to be the parts in green, right? And so if apply this commit will, and then you put the rest of that would be your subject line, right? So here's an example. It says if apply this commit will refactor subsystem X for readability, upgrade getting started documentation, remove deprecated methods, release version 1.0. And it's easier to see once you see some counter examples of that. So fix bug with Y, right? That's not how you want to format it. Here's another one, changing behavior of X, more fixes for broken stuff. That's not going to help you when you're going through a long list of commits trying to figure out what's going on there. All right. Sweet new API methods, none of that, right? And here's the thing, I think normally when you're committing, you've already spent a lot of time in the actual script or the code or whatever, and you're like, I just want to check this in. So you just put in some random thing like new code or fix the problem, something like that. And it doesn't seem important until later on you're like, well, either you're reviewing someone else's code and you're trying to figure out exactly what's going on, what they're working on, or when did this problem likely get introduced, and you're gonna it's gonna be a lot harder to find those things if those commit messages are not good. Even for yourself, again, we mentioned last time that even if you're working on a team by yourself, this git commit message is a message to yourself in the future. All right, so if you don't want to give your future self a hard time, take a few minutes and just write a nice, clean git commit message. And if you mess up and you don't write good commit messages, there's a way that you can go back and change that. But it's better if you do it the right way the first time, because there are consequences otherwise. All right, any questions on that? Those are like very soft. Yeah, Andrew.
How do I go back and change the commit message? I've already messed up.
All right, we'll touch on that. The answer to that is mostly rebasing, but we'll touch on rebasing in particular. All right. Any other questions? Bill? Yes, there is an amend option. Actually, yeah, Bill, good point. So you can amend the commits. Well, correct me if I'm wrong, Bill, but can you amend a commit message 3 commits ago? Yeah. So I think you can amend the most recent one.
But it's additive only then? Meaning you can't go back and remove previous commit messages
for the amend part, I think it's additive. It'll go back one commit.
Right.
But if you need to go back, say, let's say 3 commits ago, you want to change how that was worded, then I think you need to do an interactive rebase, and that'll let you change the messaging there. But there is we'll touch on what the pros and cons of that are in a little bit. So you want your changes to be ACID. Anyone know what ACID means? ACID. Okay. So in databases, usually it's like atomic, right? You want your changes to either all go in or not go in at all, right? They mean something similar to that. So you want your changes to be atomic, which means that at any given point in time, I can pull one of those commits out, and whatever it is should be in a working state, right? You want your change to be self-contained. You want it to be in a consistent state. This is the one where it's you don't want syntax errors in there or build, or make sure the code builds, make sure there's no failing tests, that sort of thing, if possible. Now, last time I did this one, Christine, she's one of the active members in our dev group. She's like, yeah, it's not reasonable, it's not practical, and she's correct, right? I try to do this as best as can. You want to aim for this, but if you don't, let's say you are in the middle of something, it's like, man, it's 5 o'clock and I'm going home, and you want to commit that message in. One of the standards I've seen is to put WIP in front of it, or it basically stands for work in progress. Some of the tooling will actually take up that WIP and it will do special things for it, like it won't run a build, or it won't let you merge that WIP commit into master or something like that. So it'll kind of help protect you in some ways there. But aim to have consistent state. That's what you really want, because then you can pull that commit out and start from there or branch from there or whatever, and you're in a known good state. Does that make sense? Any questions there? There's not a lot of hands-on in this one, and there's only probably like 14 slides. So we'll probably not go we won't go the whole hour and a half for sure. But I just want to make sure everyone gets all their questions answered and stuff. Cool. All right. So you want your changes to be incremental and small. So this is the I in ACID. you want it to be documented. We just talked about good commit messages. So this is the ACID as far as source control Git is concerned, which is slightly different from ACID in databases, but overloaded terms and acronyms. We're not unused to that here at NASA. Double negative, not good. All right, so git ignore. Anyone familiar with git ignore? Yeah. Anyone want to take a stab at explaining it for the group? All right, so git ignore is your friend. All right, Bill.
It's a dot file, invisible file, prefaced by the dot, which is just a list of all files you don't ever really need to want to be committed.
Exactly. Yeah, that's perfect. So git ignore is going to be your friend. It's going to basically help you omit files and folders from your source control repo. Certain things you don't want to check in, right? So what do you want to ignore? That's the question. What types of things do you want to ignore? Someone said logs. Yep, perfect. That's a great one. You don't want to commit your logs, right? Anything else?
Build directories and stuff.
Yeah, build directories. Perfect. Yeah. So your binaries, depending on what those are, if those binaries are part of your actual code and you need that to actually run, then you want to commit that, right? But if those binaries are outputs from your code that are generated from your code, then you don't want to commit that.
You don't want to commit your SSH private key.
That is a top one, right? All right, so we're going to go through this a little bit. So generated outputs, external dependencies, like your packages, so your node modules, that sort of thing. You don't want to check those in. Those are someone else's code. You want to check in how that gets integrated into your code, but not the actual sources themselves. IDE related files, so your local configuration for your IDE, that sort of thing. Don't check that in because that's just going to screw with someone else when they go to pull that code down. And they're like, well, why isn't it built? Because it has Andre Young path in it. That doesn't make sense, right? Your local configuration, you don't want to do that. In yellow, your secrets, you're not checking your passwords. Don't do it. It's in history. It's very difficult to get back out of it if you do. So take your secrets and all those things, put them in try to like an environment variable file or something like that, and git ignore that file, right? Maybe you can have one file that you put in that has dummy variables in it, just so people are putting your README how to instantiate that file, how to create that file as an example, but don't check that file in, right? Which also begs the point that you don't want your secrets mixed in with your actual code, right? That should be separate, if at all. Well, that should be separate, point blank. Which means, let's say you have a web config file, which there's an area in there for connecting to your SQL Server database. Take that out. There's ways of doing it. You can have that configuration file point to the secrets file, say, get my password from over there, get my route from over there, right? Try not to mix that stuff in with your repo. Okay? So how do we do this? You can add a relative path. I don't know why this is jumping ahead too every time I click it. So relative path to the folder or file. You can use, let's say, I think I'm going to try to use some examples here, but glob patterns. Anyone familiar with the glob pattern is? So it's just basically like, I say Andre folder / // means every subfolder below that, right? Everything in that folder. Or you can do star.jpg and say everything that's a JPEG, and we can add that in, or ignore all those files. And here's the beauty about this too. We talked about community. If you go to that URL, there is a list of default git ignore files for almost every single project type, right? And depending on your project type, what you want to ignore may be different, right? You can discover all these things by yourself, or you can just use what someone else is already leveraging and start there. And yours will actually end up, you'll have to edit it and do other things to it, but it'll be a good starting point, right? So let me show you what one of those actually looks like, if I can find one. Let's see. fuel. All right. So this is my get ignore file for one of my projects. You notice there's a lot of stuff in here that I'm ignoring. Most of this is not mine. I got this from one of those default implementations. Can everyone see that? It's not really, I guess, not really necessary that you see it yet, but it's ignoring a bunch of things that are part of that project type that I may not want to ignore, or that I may not want to commit. Starting, let's say here, is my stuff, right? So I have a web API project and I'm putting a bunch of files in there. All these files are generated. Everything in this path is generated stuff. So I don't want to check it in because every time the source changes or every time I run a build, this is going to change. And I don't want to commit that every single time, right? I don't want that noise in my thing. Someone else mentioned logs. So here's my log folder. I don't want that one going in. These are output folders for like when I add a file, an avatar or something like that. I don't want that getting checked in, right? Every time I do that. Node modules is a big one. That's my package manager folder for NPM. So I don't want to check that in, right? Let's see. Environment variable, right? I don't want to check my environment variable in. That's the one that has my passwords in it. But don't do that. Right? I was looking to see if there was, oh, here's one. So anything that has 404.whatever.html, don't check it in. All right. Don't know why specifically I put that one in there, but I think it was a problem somewhere. Right. So that's an example of one of the glove patterns. Here's another one. Everything that's in that smart admin plugin subfolder and any folder below it, I don't want any of that stuff going into my repository. All right. So this is an example of a get ignore file. Any questions on this so far? Yeah.
So when you commit your project, the Git program will automatically look at your Git ignore file as it's uploading.
Mm-hmm. Actually, as you're making changes, it's looking at your get ignore file, and it won't include those changes if it's in the get ignore file. So, for example, say you notice over here, this is changing. So that file's changed. Actually, let me change one that's actually not going to require me to build in order to see it. Node modules. This is probably not a good idea, but we're going to do it anyway. See, this is changing over here. So I went from one file change to 5,000 file changes. That's because all my packages are now starting to be tracked by Git. Right? There's a good reason why you do not want to include your node modules folder or any of your package folders, because it's going to track that top level package and everything below it. You don't want that. You'll start.
Those packages guaranteed to be there forever?
No, you can get rid of them. It's just a hassle. You can get rid of them.
If you don't check it in and your app runs in production for 10 years and someone wants a fix to it.
Yeah. So there's a couple ways you can do it, right? So depending on your package manager, how that treats it, like most package managers, they'll give you a path to that specific thing. And you can say this specific version, and then you're trusting that package manager to be around 10 years from now, right? Now, if you don't trust them to be around that long, you can vendor your actual dependencies. But that gets a little weird. You're starting to bloat your system, your repository. And every time that sub thing changes, you're bringing all those things in. Yeah. What you can do probably as well is actually to go and save those packages somewhere else, right? Not in your repository, but like vendor them into a file system somewhere, and then depend on that instead of actually depending on the package manager. By default, I would try to go with the package manager first. That's the simplest way. Chances are most of these package managers are going to be around for a while, and if they're not going to be around, they'll give you plenty of warning before that happens. So, for example, you see Bower components in here. Bower is more or less dead. I know that. I've known that for about 1.5 years now. And eventually I will go in and fix that. But they're not gone. They're just, people aren't really using it anymore. So I know I need to start moving off of it and putting my packages somewhere else. All right, so that would be a work item in my backlog that I need to resolve. And if I can't resolve it before a certain period of time, then I'll just vendor those things somewhere else. Does that make sense?
Yeah, but what if you leave?
Mm-hmm.
The person that replaces you
Isn't keeping up to date with this stuff. That's a whole different issue that I think a lot of places have, including us, where just because a project is working doesn't mean there's not bit decay, right? Over time, the ground shifts below you, right? And if those projects aren't being maintained, you're going to run into these problems regardless of your source control tool or anything else. Right? I think that's kind of out of scope for this, but there should be a regular maintenance schedule for those things. Any other questions so far on this part that get ignored? Dan.
When you have multiple boxes, you have to have operating activity more than all this.
No, you would check that get ignore in to your repository. So those sandboxes should just be instances of the code in your repository, right? So the differences in those sandboxes are probably going to be path related or specific things related to that particular sandbox for that particular dev or user. And those things you don't want to be checked in. They should be configuration stuff that's outside of it. Environment variables that change it per environment, your repo, but you should have one repo for all your environments. Does that answer your question, Dan?
Yes, no, the thing is, but is that getting more of them you can share with all the other.
Yes, you want that get ignore file gets checked in with your repo, right? So when someone brings that file, that repository down, they'll get that get ignore file as well. All right. And if it doesn't answer your question, then let me know because we'll answer it. Anthony, you had a question?
Yeah, the getting more files created within the
I don't know if it's created automatically for you. A lot of IDEs and tools will create it for you automatically, but I don't know if it by default just running git init is if it's going to create it. If it does create it, it's going to be more or less bare bones. It's going to be empty. It's probably just going to ignore very rudimentary things. You still will have to go in and edit that file or get that that file from this website. And this is updated pretty regularly too as well. All right. Good questions. Any other questions on get ignore? Anthony, go ahead. You just add a file. All right. Yeah. Just add a file, call it .getignore, and that it'll start tracking it right away. It'll look for that file, that extension name.
Is it only for that level and below?
Yes.
So if you put a get ignore in a subdirectory, does it only ignore from that subdirectory down?
That's a good point. Yes, that subdirectory. So you can have multiple get ignore files. All right. So you can have one at the top level root, and then you can have sub ones and subfolders. Just be aware that they're there because they'll treat those subdirectories differently. But that's a great question. I actually, when I was prepping for this, I realized that I had 2 get ignore files in my my overall solution. I didn't break anything, but it was just good to know. Yeah.
All right, so to piggyback off this question, if I have 2 get ignore files, and the first set, I want to ignore something, but the second set, I don't want to ignore it. Well, the 2.
So how does it resolve the conflict?
Yes.
I believe it's going to take the higher level one. Right. The only reason I say that is because when I discovered that those 2 get ignores, when I went into that subfolder and did a git status, it showed me a lot of things that were not tracked because it didn't have all those things being the get ignore file. But when I commit my stuff, it's not tracking those at the higher level. So I think if you went into that subdirectory where that get ignore was and you did a git commit there, it'll treat that one as the higher level one. But most times you do your commits, you're doing it at the root level So it'll treat that one. I think maybe it's the one that's closest, but the one that I've always seen that work is the one that's at my highest root level, because that's where I do most of my commit messages. So short answer to that is, I don't know. We have to figure it out. My guess is that the one that at the root level is the one that's going to win, based on my experiences of what's happened to me so far, if you're committing at that level. That's a good question, though. Leighton.
If you are ready with some
That's a good question as well. It will not go back and take the stuff out of your history. It'll stop tracking it from that point forward, but it won't remove those things. You'll have to do, I think, git RM or something like that, and you have to go in and start making destructive changes to your history. And we'll talk a little bit about that in a minute, but it won't. That's a good question, because it won't. If you accidentally committed all type of big binary files and all this other junk, all that stuff is in your repo. Now, if someone does a git pull after that, after you've ignored it, they won't see that in their working directory because you removed it, but it'll still be in the git history. So if they go back to a previous commit, it'll show up. That's a good question. I think that's happened to us before. So we start learning about git ignore. So another good reason for git ignore is that you want to keep your git repo size down as much as you can. There's a question about binary files, large binary files. We're going to touch on that, because initially we were ignoring those, but if those are key part of your system, you don't want to ignore that. You want that in with your repo. You just don't want it in. We'll talk on that a little bit later. You just don't want it in your actual repo. All right, so git commit hooks. Anyone familiar with these? Heard of these? They're pretty cool. All right, so git commit hooks, let's see. There's two sides. You can have client-side hooks. You can have server-side hooks. I mentioned there's a reference there that we won't go into. They're stored in your Git folder. Remember last time we mentioned that there's a hidden Git folder. Whenever you do git init, it creates that hidden .git folder. If you go into that hidden folder and you go into /hooks, you'll see all your git commit hooks. So let's see an example of that. So here's the Mars project. And Mars, we're tracking it using Git. If I do into the Git folder and then hooks, it shows all the Git commit hooks that are there. Depending on when you create your repo, if you create your repo now with a modern version of Git, it'll put these samples in there for you. When I went looking for this in the older repo that I started like in 2014, they weren't there. But the newer repos, when you do a git init, if you have a newer modern version of Git, it'll create these samples for you. So I think I jumped ahead a little bit. So let's just, before we go back into the slides, I'll show you what some of those commits hooks look like, the samples. So this is a sample. It's going to be basically a script. Anything that returns a 1 or a 0 is okay for this script, right? And so what can you do with some of these commit hooks? You can verify that you have a commit message, right? You can verify how the commit message is formatted, right? So let's say you had a standard and you wanted to say every time there's a commit, you need to relate it back to a work item. You can do that in the git commit hook, right? To say, okay, what if every time you commit it or every time you push to the central repo, you want to make sure that the build actually works before integrating or pushing that code. You can do that in a git commit hook, right? And there's a couple other things you can do in there as well. You have, so those, most of the ones I just mentioned were client side, but there are server side ones as well. Rebasing, we're going to touch on that a little bit later. Rebasing can be kind of scary. So one of the examples I saw was like every time someone did rebase, they say, nope, can't do that. Don't do that. All right, you can do that too as well. As long as you return a 1, I believe, from your script, it'll actually it'll stop the process. Some of them are also, they don't stop things from happening. They just kind of let you know after this thing happens. So let's say you did a commit. There's a post commit one, I believe. Post update, I believe. You can use that for notifications, things of that nature, right? So let's go back to the sample. All right. What can we do? Client side. Mention some of those. All right, so the server side commit hooks. Let's say every time you do a push to your server, your central repository, you want to run a build and run some tests, do a bunch of other things on the server. You can use a commit hook for that, right? Let's say you want to you're on full-on CI and CD, and you're actually, every time someone does a commit, if all these things pass, you're pushing it to production. You know, you're like full-on DevOps. A lot of those things are triggered by commit hooks. The commit hook triggers the process, and it runs through the process. So a lot of things you can do with commit hooks. You can also protect. You can have protected branches. Let's say you have policies in place where you're saying, like we mentioned this last time, if every time I do a commit, Damon has to approve, then you can do that in the commit hook, right? And some examples of that, I believe we have. All right, so this is one of my projects, and this is just a UI that's on top of it, but it's all based on commit hooks. And when we say there needs to be a minimum number of reviewers, there needs to be a work item that's associated with it. Any comments need to be closed out. Actually, not necessarily, but optionally. And there's a bunch of other things, other build policies that we can put in there, right? And all these things are based on Git commit hooks. So they're pretty powerful indeed. It kind of lets you script the things around your source control. You don't have to use it. Sometimes the tools you use will be using it on your behalf, but it's just good to know that they're there just in case you want to dive in and do a little bit extra there. Any questions on Git commit hooks? Okay, I am jumped all the way ahead. Okay. I guess I didn't do the little slide thing for this one. All right, so some Git commands. There's a reference here as well. It gives you a nice layout of those Git commands. Actually, we'll jump over there. And it divides them up by subheadings, like topic areas. So branching and merging, sharing and updating, inspecting and comparing, patching, debugging. So last time I mentioned this, and we'll correct this later, I mentioned log, and I was like, that's a way of easily finding where something went wrong. I was wrong. I forgot. It's bisect. That's the one that and we'll look at that one in a few minutes. Bisect is the actual thing that helps you determine when something went awry. This one's interesting as well. So for your Subversion users, did you know you can use Git for Subversion? Right? So you can commit all your files locally using Git, use Git completely locally, and then push that up to a Subversion repository. And that's fully supported, although they mentioned in there that that's a temporary solution as you're migrating between the two, right? RM, we mentioned before, if you want to remove things from the history, then that's what you're going to use, right? Add, we mentioned before. Status, we mentioned before. Commit, we mentioned before. Reset, we'll touch on a little bit today. Fetch, pull. So there's a bunch of them there. And each one of them, if you go into them, they give you a very good rundown of it, of exactly what is related to that, how you use it, what all the sub options are, that sort of thing. Your eyes can glaze over with all those things. I would just say, keep this as a cheat sheet. And if you need to do something, then refer to it. If you're the documentation person that needs to go and read all the specs, then by all means, have at it. I'm not that person. But yeah, so that's all there for you. All right. So a couple of useful ones. Someone mentioned last time, we're in the test that we did, or the run through we did, we start off with a bare bone. There was no repo, and we created the repo. That's not likely the case that you're going to be using it. So git clone is where you would start from if you had an existing project. You do git clone, and you either give it the path to where your repository is, or the remote repo where your repository is, and that'll clone all those files down, that repo down to your local environment. All right. Git blame. I wish I didn't have this thing actually showed up, but it's the naming is unfortunate. But basically, what that does is show you exactly who changed the file. All right, who's the last person that changed that line of code that you're in, which is really, really useful. Show you an example of what that looks like as it shows up in your tooling. Let's say, for example, can you guys see that? It's kind of hard to see. I did not change those. Right. So you see where it says Andre Young 2 months ago, and it has this message here. That's basically get blame at work. The tool is integrating that in for me, so I can see that in line with my code. But if you didn't have that, you can just do get blame on that line, and it'll show you the same information. Right. Another reason why I love Visual Studio Code. Awesome little text editor. Okay. Git config. So we're going to go into a little bit, like there are some things where you, by default, the editor I believe is Vim or something like that. You can actually change the default editor for your source control. So I've done that because I could not. I was trying to do a merge conflict, and I got the merge conflict resolved, and I couldn't get out of the editor because I didn't know how to exit Vim. So instead of me looking that up every time I have to do a merge conflict, I just changed my editor to something I actually like. And you can do that, and you can do it globally, which is this command here. No, sorry, I've jumped ahead. I really don't like that editor. So you can create aliases. So let's say you have a couple tasks that you do repetitively. You don't want to type it all the way out. You can create an alias for that command, and then just type that command. So in this case, I'm aliasing the checkout command with CO. So if I do get CO, it'll check out. All right. This is useful, but again, if you're sharing your project with other people, I think this global one will actually do it just on your local machine. But I think if you put this into the repo Git attributes, just be aware of that, right? So that you're not writing this cryptic DSL that no one else understands. Right. You can create tags as well. So let's say you wanted to tag your releases. We mentioned this last time. Then you just do git tag, and then whatever you want the tag to be will be next, right? You can optionally put in a commit ID. So let's say you wanted to tag a commit that was like 5 commits ago. Just grab that commit ID and then you create that tag on there, just adding a pointer to that commit, right? You can search through your directory as well. Let's say you want to find out where food was in your directory. Just scrap over that. Subversion, we already mentioned. If you have, you can run Git locally and then connect to a Subversion remotely. Git bisect is the one I want to show you guys, or I was telling you guys about last time. And what we'll do is we'll look at this really quickly and make sure I don't kill everybody's ears.